First of all, good afternoon, and thank you very much for the invitation to participate in this event. I am honored and delighted to be here today. During the next 30 minutes, I'm going to talk about the air taxi, also called flying cars, that we have developed at the largest technology center in Spain, Tecnalia, and which we are now going to take to a higher level of maturity, higher technology readiness level. Well, this is the index of the presentation that I am going to present. I have divided in 4 sections. The theme, the trajectory in the traditional aeronautics sector, skills and partnerships. The second chapter will be the opportunity, in which I will explain a new aeronautics ecosystem, major global initiatives, and the third chapter will be the solution. 15-15 vision, proprietary technologies, competitive advantages, key first generation product capabilities, and finally, the value creation roadmap, where additional technology applications will be explained and the key stages and milestones of the development. Okay, well, we'd like to present ourselves through this slide. This is who we are and what we do. These are the 4 magic steps that define us and that we believe few small teams like ours can perform all of them. We are capable of forecasting future scenarios, identifying the most interesting business opportunities in these scenarios, devising new concepts, products, and materializing through prototypes, building them, and finally being in charge of their validation. We believe that this is our true value, and we believe that we are certainly good at doing it. Okay, and this is how we implement it. We acquire tacit knowledge in a new field. So we internalize new information, then we share this knowledge with other departments within Tecnalia, we socialize, and then we externalize. We contrast it with our research partners and companies, creating but also justifying these new concepts. And finally, we, through this combination, we build prototypes and we disseminate the knowledge, and that's the knowledge generation spiral that we apply. Well, after this introduction, I now want to explain how we have achieved the development of an air taxi, which has been our roadmap. I worked in Tecnalia since 2001, and during the first 9 years, our team was the product development department that supported the materials unit. So we built different prototypes of products and also machines to test new production processes of new materials for different sectors and markets. But since 2011, we specialized in aeronautics, and more precisely in the electrification of this sector. As it happened in automotive sector in 2000 decade, the electrification of the aircraft started through the hydraulic and pneumatic systems, as for example, cargo doors, secondary flight controllers, landing gears, and finally, primary flight controllers. Sorry, I don't know if, at that moment, our first approach was the development of test. At that moment, our first approach was the development of test benches for the. Sorry, I have some. I don't know if you are seeing there some. Yeah, I think that there is a problem there. Sorry. Do you see now my screen? Sorry? Yeah.
Yes, we can see the screen, Dr.
Okay,
Lasa.
okay. I don't know if there was a problem. Okay.
Oh, we are on page number 5.
Yeah, thank you. At that moment, our first approach was the development of test benches for the new electric systems, because we felt very comfortable working on this. But immediately we observed that we needed to jump to the intelligence, to the electronics of these systems, because our position will be much stronger in this new sector. So we started designing the electronic control units, hardware, software, and control for the new electrical systems, main landing gears, and primary flight controllers. In 2017, we observed some evidences that forecast a great revolution in the sector, and even started to talk about a new sector beyond traditional aeronautics as we knew it until that moment. We named this new sector New Aeronautics, and we decided that we must perform a strategic analysis to know where we should reposition ourselves within the traditional aeronautics and the new aeronautics. The first decision was to start working in the control of a higher layer of the aircraft, the network of the aircraft, not working only in the systems and subsystems control. We also decided to take advantage of our specialization in the control of electric motors at systems level, and we have been working in the distributed electric propulsion, jumping to the design of new electric aircraft concepts. Well, as I have said, the electrification of the propulsion made it possible to launch new aircraft concept development. A great revolution in such a conservative sector as aeronautics. But why was it possible now and not some years ago? We concluded that the electronics and batteries' great evolution during last years on one hand, and the evolution of the electric motor on the other hand, made it possible. For example, a turbine of a big aircraft can reach up to 20,000 parts, while an electric motor can have around 40-50 parts. The implementation of the electric motors eliminates entry barriers linked to the need for strong investments and technology, as it has happened in automotive sector. Okay, and these are the main keys that explain this great revolution and the beginning of a new era, urban air mobility. To describe this whole new world, I would like to share a series of videos. The first one is a video of Airbus that gives us their vision of the future urban airspace. And, urban airspace will transport people and goods on demand. Electric takeoff and landing vehicles divided into different groups. For example, hybrid vehicles, land and air vehicles like this one. This project was already cancelled. 4 passenger air taxis as the city Airbus, and 1 passenger air taxi as Bahana. But we will also have goods delivery drones. And of course, the first step is the definition of the new air space with the collaboration between cities and regulators for the safe integration for all types of air vehicles. Within this
that is equally affordable, eco-efficient,
urban airspace, all the infrastructure, the corridor, and vertiport must be defined,
air taxis
as well as all
and
the
airspace
unmanned
minimal
air
impact,
traffic
while at the
management.
same time
That
developing
in
more
Europe
intelligent,
is called
autonomous,
US
and
space.
decentralized
It
air
is
traffic
being
management
defined since
solutions that can
2013,
safely and
when the
efficiently
first projects for its development started.
airspace.
USA, China, and Japan are also developing their own unmanned traffic management.
It's all about giving ourselves. With rapid advances in
And
electrification,
after this global view of the urban air mobility, I'm going to share with you
a
three
new class
different
of
videos.
vehicles is
The
becoming
first one is related to the delivery of goods in Africa.
electric takeoff
Then
and
another
landing,
video of delivery of goods, but
flat
in this case
hour-long
in Europe. And
just
finally, Uber's point of view regarding people transport from the city center to the periphery of the city.
to deliver on the best possible urban air mobility experience.
The first video shows the case of Zipline,
And safe.
one of the most important drone operators in the world, from USA, and that a few years ago decided to develop all its technology and business model in Africa and South America, since in many countries they did not have a defined legislation for UAV airspace.
In the same airspace.
Many companies have followed in their footsteps and developed the first prototypes and demos in these countries. In the video that you have seen, you could see Zipline, how they have connected all the hospitals in Rwanda by air, carrying medicines and blood bags. The next video shows the delivery of goods in Europe, in Reykjavik, the capital city of Iceland. In this case, we are talking about the delivery of food inside the city by means of well-defined corridors. And this is already a reality. There is a company, AHA, that is carrying out food delivery. We are no longer talking about the future. This is already happening now in Europe and in a capital city like Reykjavik. Okay, and finally, the third video. The third video is Uber's vision regarding people transport between the city center and an airport located in the periphery of a big city. As we can see in this video, a woman enters in a skyscraper and takes the elevator up to the vertiport located on the roof of the building. She gets on a VTOL aircraft, vertical takeoff landing aircraft, and travels to the airport. Uber published a white paper in which they defined the viability of this type of transport. According to their calculations, an airplane like the one they were developing would be profitable today, and they gave the example of a trip like the one from Manhattan to John Fitzgerald Kennedy Airport. According to their estimation, the travel time will be reduced from 1 hour 15 minutes up to 7 minutes, as the aircraft will go in a straight line directly and reaching speeds up to 200 or 300 kilometers per hour. Not only the time, the pollution will also be reduced considerably. Okay. And after this visual introduction with 3 videos, I would like to share with you how this market is growing and which are the estimations for the next years. The figures have been defined by Lufthansa, these figures, and have been published very recently. As you can see, the estimations are very positive and the market will grow considerably in the different niches. But why we decided to develop an air taxi instead of a drone or any other system of the urban air mobility? Systems and vehicles that perhaps could be exploited much earlier than the air taxi. This decision was linked to three main reasons. First of all, we considered that the market impact would be much more important with such a disruptive product as the air taxi. We considered that it would have a great impact in the media and would attract the interest of companies. And so it has been. Secondly, as research center, from technology point of view, a product like the air taxi gave us the opportunity of performing a transverse analysis of all the different technologies of all the different technologies implemented in it. And last but not least, the people. It's much easier to motivate the team when you are developing such a product, making the immersion in a new field of study much faster. In this way, we started to analyze this new market, the air taxi market landscape, in which we observed four clear groups that are trying to position: aviation players, automotive players, startups, and technology-based companies. The venture capital investment activity in air taxi startups has increased extraordinarily, rising up to $1.115 billion in 2020. Our analysis of the air taxi market concluded that two niches were clearly defined. On the left hand, the intercity or city center to periphery air transport. On the right hand, the intracity transport inside the city center. In the first niche, the most important characteristic is the efficiency, high speeds to reach in the minimum possible time a specific point of the periphery. In this case, the vehicles resemble conventional airplanes, and a specific infrastructure is foreseen for its integration in the city, the vertiports. On the other hand, in the intracity niche, the maneuverability is a key characteristic, and therefore the vehicles look like conventional multicopters. Infrastructure is not foreseen for its integration in the city because one-passenger vehicles could even be parked in conventional car parks. We decided to develop an air taxi for the second niche, but with higher maneuverability capacity than conventional multicopters, and trying to approach intercity niche vehicles efficiency. We defined a 15-15 mission where the air taxi could perform 15 kilometers distance range or could have 15 minutes autonomy, covering the 85% of the urban center of all the cities in the world. We devised a new concept of aircraft that we called drone of drones, where a propeller is usually installed in a drone. We installed a complete drone, connected by means of a spherical joint, a passive joint that permits moving the drone in any direction. This architecture introduces three main competitive advantages: higher stability controllability in flight, much more precision in takeoff and landing maneuvers, and higher speeds in cruising mode. Now I change to slide number 19. Okay. This simulation shows the response against different wind speeds of the air taxi on the right hand and a conventional drone architecture with spheric joints fixed on the left hand. As you can see, our architecture is much more stable and the comfort of the passenger is much better as well. This competitive advantage of stability covers two key features necessary in urban air mobility: the stability in flight and the precision in landing and takeoff maneuvers. Well, and now I'm going to change to slide number 20. This slide shows the improvement in efficiency compared with conventional multicopters, reaching similar efficiency to the prototypes in the intercity niche. Tilting propellers permit the aircraft to move with minimal main cabin aerodynamic drag, because this value is constant in all the different modes and speeds, achieving 80% more efficiency than a conventional drone architecture at 100 kilometers per hour. Slide number 21. Moreover, the prototype was user-centered design, focusing on usability and acceptability aspects. Inclusivity also taking into account design for all principles and seamless urban integration. The passenger cabin was designed in a way that people can stand inside. The interior is very spacious and comfortable, and the passenger cannot see the land and propellers. It's designed just to focus the view in the sky, to make the user experience as pleasant as possible. With this purpose, a customer journey map was performed in the design stage. Slide 22. The urban integration was one of the key aspects in the design, with a reduced footprint for easy integration. Well, and in this way, we design, manufacture, integrate, tune, and finally validate the prototype. And we arrived at the great day of the maiden flight. That was very exciting, thrilling, emotional for us. And this is the slide 24 with the video. Slide 25. The final shape, the appearance of the aircraft that we are developing now is the one you can see in these images, renders of this slide. There are 4 different images that show which will be the final aspect of our aircraft. And now slide 26. Which is the value creation roadmap? In July 2019, we presented the maiden flight of Flight3 with all the media, and it was a success. It was a proof of concept, and in this stage, we performed a technical feasibility analysis of the architecture. We developed all the virtual simulations and all the necessary tests with 1.5 and 1:1 scale prototypes. Now we are in the second stage with flight tests foreseen in real conditions, optimizing the architecture and control to ensure maneuverability and efficiency. In 2020, 2022, we will have a more developed prototype closer to commercialization. This phase will be the final one, in which all the certifications and approvals must be ready. Slide 27. This slide, we want to explain that we are not only focusing in people transport. This architecture is also very interesting for aerial robotics, which has closer time horizon and lower regulation requirements. And we expect to apply it in inspection and maintenance and also advanced logistics. And just to finish, slide 28. Well, as this is an event on materials, I would like to end my keynote presentation today by first explaining that this first generation of our aerotaxi has been built using commercially available composite and metallic materials, such as steel for the aircraft arms. But for the future, urban air mobility, to be most efficient and viable from an economic and sustainability point of view, I am here today to let you know that, in my opinion, and in the opinion of my colleagues working on materials at Tecnalia, urban air mobility will bring very interesting challenges for materials scientists and engineers. We at Tecnalia envisage that breakthrough innovation in terms of materials will be key, in particular, as the success of future urban air mobility will heavily depend on the development of innovative, lightweight, composite and metallic materials, such as new types of ultra-high strength steels. By increasing the mechanical strength of the materials, less materials can be used, resulting in a lighter aerotaxi which can be much more efficient in terms of energy consumption. Furthermore, urban air mobility will pose important challenges also in terms of sustainability issues related to materials. This is, in fact, an important multisectorial challenge which we are also working actively on at Tecnalia. And it's to develop more sustainable materials, sustainable by design, which can be readily recycled and or reused. In addition, the material production processes also need to be more efficient and sustainable, more energy efficient production processes, lower CO2 emissions, lower waste generation. For the solutions to be sustainable. To conclude, breakthrough innovation in sustainable and lightweight materials will be key to enable these futuristic products to be commonplace in our lives. And that's all. Thank you very much for giving us this opportunity to be here today. And well, I will be very glad to answer you now the questions.
Thank you very much, Dr. Lasa, for that exciting presentation. I mean, to a large number of our audience, it surely would have looked like it's out of some science fiction. I mean, it's very similar to that, right? You get into an air taxi and you fly out, land at some place and run out of it. I guess at some point in time, that's probably the future of mobility. Who knows? But and therefore, Dr. Lasa, there are a few questions since we have a few minutes before we close. There are a few questions. A large number of these questions are around, the feasibility, safety, etc. So the first question is, while technically we seem to have made progress in terms of the vehicles or air taxis, both for logistics purposes as well as for people movement, what are the big challenges you see from the point of view of regulation, traffic management, integration with other forms of mobility, etc.? Any thoughts on that? And do you have any government thinking, policy thinking on that for all of us, to understand? We know that the government of Dubai, for example, is looking at deploying air taxis in a big way. So, any thoughts on that?
Yes. Yes, well, the regulations all over the world are very different, but country by country. For example, there were 5 cities in the world that they have foreseen flight demos in 2020. Because of the COVID, everything has been delayed. But Dallas, Los Angeles, Tokyo, Shanghai, and Singapore and Dubai were deploying first tests inside the city, and they were connecting to helicopter routes just to take these first flights inside the city. There are different roadmaps. Europe, China, Japan, United States have their own roadmaps, and all these roadmaps says that the deployment of the industry that will respond to this new sector will be made in this decade. For 2030, all these roadmaps of different countries say that in 2030, this will be a reality. And for example, in Europe, we have already some draft versions of these new regulations.
Okay, thank you. Thank you. So we are saying by 2030, we hope to see some versions of air taxi services to go commercial and primarily for moving people
Yes.
within city limits. Right. Thank you. So there are some other questions. The second question is around the safety. So obviously, these are going to be unmanned aerial taxis, and therefore it will depend a lot on the software and the robustness and integrity of the software, etc. Also, and therefore the question is, what happens in a situation? How do you build redundancy? What happens in a situation when there are issues with software? How do you ensure the safety of the passengers as well as the safety of the rest of the people around the aircraft?
Okay. Some companies are they are foreseeing the first flights will be with pilot. For example, Uber was thinking of deploying in Dallas and Los Angeles with a pilot and 4-passenger air taxi. But it's true that they will be autonomous. The vision of this urban air mobility sector is that all the improvements and all the advances that are being done in automotive sector will be very interesting for the aircraft sector. Why? Because their vision is that it's much more complicated, the autonomous drive in land with land vehicles than air vehicles, because we have people, we have animals, we have different things, and they think that they will take advantage of all this knowledge and the knowledge that we have already now with the aircraft, and that this will run very quickly and very fast in this new sector, faster due to all the advances that they are already being done in the automotive sector. And the safety, I would like also to say that, as I said, once that you have no turbines and you have implemented electric motors, all these new systems that we have seen in different projects, they have 16, 20 or 40 electric motors. It's much cheaper, the technology, and you can implement many motors, and in this way you have redundancy in the most critical part of an aircraft. So it's very important to be electric as They are all these new air taxis.
All right, thank you. Thank you, Dr. Lasa. There's one specific question on the prototypes that you have designed, and maybe the others are also working on similar prototypes of air taxis. And this is on materials. While you had a slide on the expectations from materials, this question specifically is on what kind of materials were used for the prototypes, and do you see the materials that you have used on the prototypes as the choice going ahead as you hope to commercialize these air taxis?
Well, here we have done a prototype, and as I said, we have commercial materials and commercial, well, we saw which was the commercial availability to integrate in our first prototype. Now that we are developing a new aircraft, we are already changing the design, because we have some parts that we must change due to the lightweight. As I said, we used composites for the arms of the multicopters, also for the arm of the aircraft and the cabin, and all the connections were metallic. Metallic links between different composite parts, but there are many connections between all these different parts. Even, well, now we are just analyzing which are the best choices to change. Well, we are just now in this phase of redesign of this product.
Okay. There's one other question, which is around the size of the air taxis and the general passenger, the number of passengers, like we are already seeing in the current forms of mobility in taxis. For example, we're talking about between 3 to 4 people being transported, generally speaking, in an IC engine or in a normal automotive car. And we all know the future discussions or let's say the forecasts are that the future vehicles, as they become autonomous and connected, we are likely to increase the density of passengers in the vehicles of the future from the current 3 to 4 to between 5 to 7. So if I bring that into air taxis, that concept into air taxis, what's the kind of passenger density you are looking at now and maybe 10, 15 years into the future in the air taxi space?
Okay, now the density of passengers in the intra-city niche, as I have explained, inside the city center, this transport, we are thinking about one passenger air taxis. Why? Because the propellers, due to the now the technology readiness of the electric motors, and we need propellers that have a quite big size. The problem is also the batteries and the weight of the batteries. So just for one passenger, just to have an idea, the size of the aircraft is more or less as one car, land car, for a passenger. I mean, this aircraft for one passenger would take all the space of a car park inside the city. However, in the intercity transport from the city center, for example, to the airport, in this case, we are thinking about aircraft concepts. I mean, you can have much more space for wings, and as you have wings, you have lift, and you can take off much more weight. So in this case, some companies are thinking about 4 passengers because you have lift. There are not very large distances, 40, 50 kilometers, and you introduce lift, and you have VTOL systems that vertical takeoff landing aircraft that take off and land like helicopters, and then they go in cruising mode like aircrafts. So 2 niches, 1 passenger, 4 passengers just today. In 15 years, I suppose that all this density will increase.
Okay, thank you. There are a number of other questions, Dr. Lasa, but I think we are running out of time. So I will probably take one more question, but to all those who have posted the questions, we will make sure that these questions are routed to Dr. Lasa, and I'm sure Dr. Lasa, you might want to respond to them in case I have not already taken those questions on board. And please don't hesitate to post more questions. We will make sure that they are adequately responded to. Just one last question, which is in connection with also what our CEO mentioned in terms of sustainability and carbon footprint. So in the current mobility space, we have always been talking about, we started with, let's say, kilometers per gallon or kilometers per liter consumption, etc. We moved to carbon intensity per kilometer traveled, like CO2 grams per kilometer, etc. And I think slowly we are moving to a situation where we are talking about carbon footprint or measurement in terms of sustainability as CO2, for example, per passenger kilometer. In that context, how do you see the air taxis comparing with, let's say, electric vehicles, battery electric vehicles, which given that the power sector and energy is likely to be decarbonized faster in the future, how do you see air taxis comparing with, let's say, other forms of mobility in terms of the carbon footprint as per passenger kilometer?
Well,
that's likely to be a crucial element.
Yes. Well, it's difficult to conclude now, to have a conclusion, but we have some calculations that I have before cited in my speech. There are some companies that now give their services. They give this service of transport in the cities by land, and they have made some estimations, some calculations, and they have seen that, for example, in a city in which we have the airport 40 or 50 kilometers far from the city center, now, due to the roads, how they are in the city, they can last like 1 hour, 15 minutes to reach up to the airport due to the traffic jams, etc. The difference is that if we have an aircraft in the roof of a skyscraper and we can go in a straight line directly to the airport, 40 kilometers or 50 kilometers far from the city center, they estimate that with 200, 300 kilometers per hour, we can reduce this time extraordinarily. I mean, we can do it in 7, 10, 12 minutes. So we reduce the time, but we reduce also all the emissions, carbon emissions, and they see that they will be much more efficient and the pollution will be reduced. And that's why companies as, for example, Uber, but there are also Lilium and some other companies in Germany that they have seen the opportunity there. And they see that it's possible to do it now and that it will be profitable. And that's why we think that from this point of view, this new transport will be very interesting.
Okay, thank you. Thank you very much, Dr. Lasa. With that, I think we will close.